I am Thomas Pavey. I am an engineer in marine ecology and I've been working with Sulu-Bay since 2015. At that time we were focusing the project on ecosystem restoration, so restoring the mangrove, the land, but also the coral reef. During our surveys of the reef surrounding Pangatalan Island, we discovered that the reef has lost its structural integrity in some parts. The problem we have with the loss of the structural integrity is that a lot of corals naturally recruited by the reef will die within months or a year because they don't have a solid support to grow on. So we decided to design our own artificial reef, which we called SRP for Sulu-Reef-Prosthesis. Since the beginning of the Sea Academy project, we have implemented new SRP groups on the reef in different environmental areas. Between 2017 and 2021, we have been focusing our surveys on coral fragments only on the SRP to see first if they have a good rate of survival. The results were 76% of survival after more than a year, so this is pretty good. But coral reefs are not only made of corals, so it's not because the corals are growing well that actually the resiliency of the reef is complete. To improve our knowledge about the ecological dynamics that are happening on the SRPs, we started to implement other methods. One of the methods we use is called photoquadrat, so we will take pictures of a small quadrat. In this case it's 8 by 8 centimeters. What we want to see in this quadrat is the evolution of the benthic community. What we call benthic community is all organisms living attached to a substrate. So it can be vegetal or animal, but it's all living organisms attached to the reef. As well as observing what is growing on the SRP, we also want to see what kind of fishes are using the SRPs or hiding between them. To do this, we implement two methodologies. One is by counting visually all the fishes by species for 5 minutes. But we also use a time-lapse methodology, which is setting up a camera on the reef for 2 hours and it will take a picture every minute. So we can then count the fish and the species on the pictures and do statistical analysis. We also want to understand how many naturally recruited corals are growing on the SRP. What we call coral recruits are coral colonies that are less than 5 millimeters wide. It's important for us to know that because, of course, we fix corals on the SRPs, but on the long term, we want to see if the SRPs are getting colonized by other species of corals and if the diversity of corals is growing over time. We also do the same counting on the natural reef using a quadrat that is 25 by 25, so we know the surface of it, and we can then compare the number of recruits per square meter within the natural reef and the SRPs. The photogrammetry is a method where we will take a lot of pictures of the same subject, and then using a computer we will modelize it and make it a three-dimensional model. We can then use this model to either observe any growth or any mortality, necrosis, but we can also calculate volumes. In this way we can see not only if the corals are surviving, but also are they growing well. Sulu-Bay has been implementing SRP since 2017, so it's been now 6 years that we can see things going on with the SRPs and corals growing, and we have a lot of feelings, but we are really excited now to see what are the scientific results of the methodology we just applied on them. And this will help Sulu-Bay to train some divers from the island and from the local community. So if they want to implement some SRPs in the future, they can do it the right way. And I'm really happy to see that after all those years, the divers from the island will continue to protect, but also facilitate the resiliency of the shark fin bay.